This video will teach you how to solve equations with integers using addition and subtraction. So all the notes from the video again should be copied down on your note sheet. Any examples, definitions, and things like that should be copied down on your note sheet. So in 6th grade you learned how to start solving equations using variables. So the goal for solving equations is to determine the value of a variable in an equation. So again, this should be copied down in your notes. And then the different parts of an equation. Y plus 7 equals negative 5. First of all, I know this is an equation because I see an equal sign. And then we can say that an equation is balanced, like a scale, and there's a left side of the equal sign, and then there's the right side of the equal sign. And then the different parts, change colors. Y is our variable, which we should know. The variable is also the unknown. We're trying to figure out the value of the variable. It can be other letters like X, P, H, any letter of the alphabet. And then we also have our constant. So you can circle the 7 is the constant. And the constant is the number by itself. So we have variable, constant, and then the left side and the right side of an equation. The next is inverse operations. Inverse operations are opposite operations that undo each other. So today we're focusing on addition and subtraction. So addition, its inverse is subtraction, they're opposites, they're inverses. And then subtraction, its inverse is addition. So in order to solve an equation, we have to do inverse operations. Next is the steps. So today we're focusing on one-step equations, so there's only one step. So step 1 is to get rid of the constant by using inverse operations. Later on, next week, we're going to be doing two-step equations and multi-step equations. So today, one-step equations. Step 1, the only step, get rid of the constant by using inverse operations. So next we'll do examples, and then what you do to one side of the equation, you must do to the other side of the equation. If you look on your notes, there's a picture that I drew of the balance. So think of it as what I do to one side, I do to the other, so we want to make it even. Oops. The balance should be even like this, it should not be like this or like that. So let's do example number 1, y plus 7 equals negative 5. Remember our step, our one and only step, is to get rid of the constant by using inverse operations. You'll also, remember also our goal is to determine the value of a variable, in this case it's y, to figure out that value in the equation. You also might have heard the phrase isolate the variable. So once we get y by itself isolated, then we'll be able to figure out its value so we can reach our goal. So let me switch colors. So our first step, our one and only step, get rid of the constant by using inverse operations. If I look here, it's y plus 7. I know 7 is my constant, so I have to use inverse operations. And everything I'm just going to work down. So you have to start thinking of solving equations from up to down. So again, get rid of the constant by using inverse operations. So I know that the opposite of adding 7 is subtracting 7. So I'm going to subtract 7 underneath. I can bring down my equal sign. Remember, what I do to one side, I have to do to the other side. So since I did this to the left side, I have to subtract 7 also from the right side. So see how it's balanced here. Then I can go ahead and draw my line. So now on my left side of my equation, this plus 7 and the minus 7, I know they cancel out, so I can cross it out. And then I just bring down what's left. On the left side, I have y remaining, so I bring down my y, bring down my equal sign, and on the right side I have to do this, which is negative 5 minus 7. So this is subtracting integers, so I know I can do keep, change, change. Keep my first number, change subtraction to addition, change the second number to its opposite. So now I have negative 5 plus negative 7. When my signs are the same, I just add and keep my sign. So y equals negative 12. Let's look at our second example. Negative 2 equals m plus 6. Again, I have to isolate the variable in order to determine its value. That's my goal. So I look on my right side. I know my constant is that plus 6, so it's positive 6. So if I'm adding 6, I know the inverse of addition is subtraction. So I'll subtract 6 from not just one side, but from both sides of my equal sign. Both sides of my equation. And then if I look on my right side, this 6 minus 6 cancels out because that equals 0. I don't even have to write the 0, I can just cancel it out. Then I bring down what's left, which is m, bring down my equal sign. Then I have to do this on the left side. So I can write it horizontally to see it better. -2 minus 6. Again, it's subtracting integers, so I can keep, change, change. Now I follow my adding integers rules. The signs are the same, so I just add and keep my sign. So m is equal to -8. And then let's look at example number 3. 7 equals -11 plus 9. So here it's a little different because my constant is in front of the variable, but I can still use inverse operations, right? So if it's -11, I know the inverse or the opposite of -11 would be +11. So I can add 11 to both sides. Remember, what I do to one side, I do to the other side. On my right side, I know -11 plus 11 will cancel out. So then I can bring down what's remaining, which is n, bring down my equal sign. Then I can just simply do this side. 7 plus 11, I know is 18. So 18 equals n. So let's look at example number 4. H minus 4 equals -5. So now we're getting into subtraction. So again, my steps are still the same. Step 1, get rid of the constant by using inverse operations. So if I look on my left side, I see that my constant is, I can start to read it as this -4. So to get rid of my constant, subtracting 4, the opposite or the inverse is adding 4, so I add 4 to both sides. What I do to one side, I do to the other side. And if I look on my left side, this -4 plus 4, I know cancels out, because any number plus its opposite will equal 0, so I can cancel those out. I bring down what's left, which is just my h, bring down my equal sign. Then I have to do what's on my right side. And if you need to write it horizontally to help you see it better, -5 plus 4. If I'm adding integers and my signs are different, remember I can just subtract. 5 minus 4 I know is equal to 1. And then since 5 has the greater absolute value, there's more negatives, it's going to be -1. So h equals -1. Let's look at example number 5. -10 is equal to c minus 8. So again, I have to get rid of the constant by using inverse operations. And then I can look on my right side here, c minus 8. I know the opposite of subtracting 8 is adding 8, because that's the inverse, so I add 8 to both sides. Remember, what you do to one side, you do to the other side. And then on my right side, the -8 plus 8, those are opposites, so then they're going to cancel out, so I'm left with c. These cancel out again because remember it equals 0. Bring down my equal sign. And then on the left side, I can do -10 plus 8. Remember, if my signs of the integers are different and I'm adding, I can just really subtract. 10 minus 8 I know is 2, and since 10 has the greater absolute value, it's going to be negative, so our answer is -2. And then let's look at our last example, 9 equals -6 plus p. Again, this one's kind of different because the constant is in front of the variable, so just look at the sign of the constant. So the opposite of -6 or subtracting 6, I know is adding 6, so I'll add 6 to both sides. On my right side, this canceled out, and I'm left with p. Bring down my equal sign. I know 9 plus 6 is 15. So 15 equals p. And then just to show you how to do a quick check, you can take whatever value you get for the variable and just plug it back in. So to do a quick check, I can do 9 equals -6 plus 15. And then if I get a true statement, then I know my variable, what my value is true. So let me erase this real quick. And so if I look on my right side, since I'm adding the integers and they're different signs, I can just subtract. So I know 15 minus 6 is equal to 9. And since there's more positives, 15 has a greater absolute value, it'll stay positive. So 9 equals 9. If it's a true statement, then I know I'm correct. So that's how you can do a quick check. After you've done the notes, complete all practice problems on the back of your sheet. Make sure you show all of your work, which is that one step. If you have questions, refer to your notes and examples if necessary.
Now this problem, we're not going to start with numbers, but with this scale. And a scale stays balanced as long as both sides of it have an equal amount on them. So let's load up our scale. Now we can see on the left side, we have an x representing some mystery amount. And with the x, we can see that we have 1, 2, 3, 4 more. So on the left side of the scale, we have x plus 4. On the right side of the scale, we can just count up that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. So we know the equation we are starting with here is x plus 4 equals 12. Our goal in this problem is to figure out what the x equals. The problem is, right now we have this plus 4 attached to our x. What we want to do is get rid of those extra 4. Using numbers, we can cancel out the plus 4 with a minus 4. But hold on, there's a problem. If I take 4 away from one side of the scale, my scale would no longer be balanced. Whenever I do something to one side of an equation, I have to do the same thing to the other side. So on the right side, I'll also take away 4, or subtract 4. Now we can go ahead and solve this equation. On the left side, plus 4 and minus 4 cancel each other out. We're left with just an x. On the right side, we have 12 minus 4. What does that equal? Well, 12 minus 4 equals 8, so we can say that x equals 8. And that's what we see in our scale as well. Now let's look at another problem, and this time we're only going to show the equation. Let's look at x minus 6 equals 8. To solve this equation, we need to get x by itself, and the problem is right now, there's a minus 6 attached to it. Well, just like we got rid of the plus 4 by subtracting 4, we'll get rid of the minus 6 by adding 6, the opposite. And remember, if we do something to one side of an equation, we have to do it to the other side. Now we can solve this equation out. Well, minus 6 and plus 6 will cancel out. We'll just have an x. And on the right side, we'll have 8 plus 6, which equals what? 8 plus 6 equals 14. So in this, x equals 14. Let's do some of these together. Let's look at the equation x plus 6 equals 4. Remember that to solve this equation, I have to get the x by itself. So I'll need to cancel out the plus 6. How can I cancel out plus 6? To get rid of the plus 6, you do the opposite. You subtract 6. And remember, if you take 6 away from one side, you have to take 6 away from the other side. When you solve out this equation, what do you get? Well, you get that the plus 6 and the minus 6 cancel each other out. You just have an x on the left. On the right side of the equation, you have 4 minus 6. Well, 4 minus 6 you can solve is negative 2. And so our answer is that x equals negative 2. Let's look at another. Let's look at the equation x minus 3 equals negative 1. Well, what is the first thing I need to do in this problem? Remember, my goal is to get the x by itself, so I have to get rid of this minus 3. We can get rid of a minus 3 by doing the opposite, by adding 3. And if we add 3 to the left, what do we need to do on the right side? Well, remember, we always do the same thing to both sides of an equation, so on the right side, we also need to add 3. Now let's solve this equation out. What do you get? Well, the minus 3 and plus 3 on the left cancel out. We're just left with an x. On the right side, we have negative 1 plus 3. That equals 2, and so in this problem, x equals 2. Now it's time for you to practice some of these on your own. Let's look at the equation x plus 8 equals 2. Solve this out, what does x equal? Well, you need to start by getting rid of the plus 8. To get rid of a plus 8, just subtract 8, and remember to do it from both sides. When you solve this out, you'll find that the plus 8 minus 8 cancel out, so you're left with just x. And on the right side, 2 minus 8 is negative 6. X equals negative 6. And now here's our last problem for this video. X minus 3.5 equals 4.8. Solve this out on your own. What do you get? Well, hopefully the decimals didn't throw you off. We treat it just like any other equation. To get x alone, we have to remove the minus 3.5. Well, we do this by doing the opposite. We add 3.5, and we do it to both sides. When you solve this out, minus 3.5 and plus 3.5, those cancel out, so you're left with just x. And on the right side, you can calculate 4.8 plus 3.5 gives you 8.3.
Be adding and subtracting today. So our first example is 8 plus negative 3. I have a number line here along the bottom just to show some positive and negative numbers. Notice 0 sits right here in the middle. Positive numbers move to the right. Negative numbers starting at 0 move to the left. So if I were to add 8 plus negative 3, I would start out by going to 8. 8 is a positive number, so again I'm moving to the right. Or negative 3. Haha! Changed it. Negative 3. There we go. So negative 3 would bring us back to being 5. So you'll see that that's how we add integers. When you're adding a positive and the negative kind of undoes the positive or goes in the opposite direction. Let me show you another example here real quick. Negative 3 plus 8. This is what that would look like. I would start at 0 and go negative 3. Then I would add 8 and I would also end up at 5. Notice we ended up at the same place whether we added 8 plus negative 3 or negative 3 plus 8. Alright, now let's switch things up a bit and make the 8 negative and see what that does. So I have 3 plus negative 8. I would start out by going positive 3, and then I would go negative 8, bringing me to negative 5. So those are 3 examples of adding integers that I wanted to show you visually on the number line. Now let's look at those 3 examples and see what we can learn from them. And we will come to basically learn the rules for adding integers out of those 3 examples. First off, the order of the numbers does not matter when you're adding. See that? 8 plus negative 3 plus positive 8. The order does not matter, and that is absolutely true. It does not determine whether it's positive or negative based on the order that it's in. Number 3, the final result, positive or negative, is based on the larger number, ignoring the signs. So, if you look at this one, the larger number is positive, 8, and so your final answer is positive 5. In this one, the larger number, again, ignoring the signs, I know negative 8 is smaller than positive 3, but 8 is bigger than 3. So if you ignore the signs, 8 is larger than 3. Therefore, the final answer will have the sign of the larger number ignoring the sign. In other words, there's more negatives than there are positives. This is another way of looking at that. Another way to say it is a larger absolute value, but I don't really want to get into absolute values too much. But if you understand what that means, then you'll also understand that. And of course, number 2, when the signs are different, we subtract the numbers. Did you see that with this one here? 8 minus 3 is 5, 8 minus 3 is 5, 8 minus 3 is 5. All of them are subtraction, really. So when the signs are different, we subtract. I have a colleague who says when the signs are different, you find the difference. I really like that. So let's try adding a couple of them. This is our practice. Go ahead and pause the recording. Try to add 15 plus a negative 3. Hopefully you're back now. This is what we would do. The signs are different, so we're going to subtract. 15 minus 3 is 12. Then we ask ourselves, is it going to be a positive 12 or a negative 12? Well, I have 15 positives and only 3 negatives, so that means I have more positives than negatives. In other words, my positive number is larger, so my final answer is going to be positive 12. Here's another one, negative 11 plus 6. The signs are different, so we find the difference. I'm subtracting. 11 minus 6 is equal to 5. Is my answer going to be positive or negative? Well, which number is bigger, 11 or 6? 11 is bigger. There are more negatives than positives, so my answer is going to be negative in the end. One note about something that's a little bit different than this, and that's when the signs are the same. Let's talk about that real quick, because this one should be real fast. When the signs are the same, you end up like this. 8 plus 2 is equal to 10. Alright, pretty straightforward. We've done that since the time we were little, when we were adding in, like, kindergarten, first grade, third grade, whatever. It's the same with negatives. Negative 7 plus negative 2 will give us negative 9. When the signs are the same, you add the numbers and keep the signs. Alright? So if the signs are the same, you add the numbers and you keep the sign. This is different than multiplying and dividing. With multiplying and dividing, you have all sorts of different rules. A negative and a negative gives you a positive. But when you are adding, you keep the sign. If I have a negative 7 and I add negative 2 more, I get an even bigger negative number. So that's an important thing. It's very different with adding and subtracting. Alright. So let's do some practice adding numbers that have the same sign. By the sign, I mean either positive or negative sign. You can pause the recording and try these two out on your own. We're back. 14 plus 3 is 17. That one may have seemed pretty easy to you. It's a positive 17 because we've done that kind of adding for a very long time. Let's move over to this one. Negative 4 plus negative 9. The signs are the same, so we add the numbers. 4 plus 9 is 13. Is it going to be a positive 13 or a negative 13? Well, we keep the sign, so it's going to be a negative 13. And that's it for adding. Adding with the same signs and adding with different signs. Now we're going to move into subtracting, and I'm going to try to show you this on the number line. It gets a little tricky at one point. But we have to just remember this. Subtracting is the same as adding a negative, or adding the opposite. Okay? So just bear with me as we go through this. 7 minus 3. 7 minus 3 gives you 4. Alright, 7 minus 3 is 4. That's pretty easy. It's the same as adding the opposite of 3. So instead of saying minus 3, we could say plus negative 3. Look at that. Adding a negative is the same thing as subtracting. Bingo! Isn't that fantastic? Now, that didn't make our lives any easier, so I don't recommend you do this, but I just wanted to illustrate it. Alright, next one. Subtracting is the same as adding the opposite. What if I get negative 3 minus 1? What would that look like on my number line? I start at 0, I go negative 3, and then I go negative 1 more, and I get negative 4. Okay. That's the same as saying negative 3 plus negative 1. See, instead of subtracting 1, we are adding the opposite. Does that make your life a little easier? Because we just learned the rules for adding a negative plus a negative gives you an even bigger negative. For me, I like seeing it this way instead. I know there's added parentheses. I know it seems a little more complicated, but I like seeing it that way because it makes a little bit more sense to me. Some people prefer to think of it like this, negative 3 minus 1. Some people want to think of it as negative 3 plus negative 1. Both ways are correct. That's a great thing about subtracting. Now let's go to this next example. And this one here is where subtracting becomes totally ridiculous, and that's when you're subtracting a negative. When I think about this, I think of a bad guy in town, and the bad guy leaves town, so you're minusing one negative person, and that gives the same as a positive, and that's really confusing too. Minus a negative is the same thing as a positive. Taking away a negative is a good thing. And that's why, like, on the number line, this looks really funky. But the way that I remember this is if I see that double negative, I immediately change it into a positive. Again, taking away a negative is a good thing. It's a positive thing. Alright? Remember, you are adding the opposite, right? So instead of subtracting negative 2, I'm going to add the opposite of negative 2. I'm going to add positive 2. I don't know if seeing it on the number line is a bit helpful at all, but just looking at that makes my life a whole lot easier, going from this subtraction question to this addition question. So let's, again, take a look at what we've learned. Subtracting is confusing, and we hate it. 3. Personally, I'd change the sign if I ever saw the negative. If I saw that double negative, I would change the sign. Most of the rest I would leave alone. This one I would change in some cases. But according to whatever you get comfortable with, you're going to learn to change the sign or not change the sign with practice. But definitely every time I see this double negative, I would absolutely change it into being a positive. And number 2, change the sign when it makes your life easier. Otherwise, just leave it as is. That's my rule with subtracting. I find it just simplifies my life. So, let's go ahead and do some practice with subtracting. I want you to pause the recording trying to subtract that 20 minus 4. Hello, we're back. 20 minus 4 is 16. That one wasn't so bad. Alright, let's move on to our next subtraction question. Negative 8 minus 7. Welcome back. I hope you paused it and actually did it. You didn't, did you? Pause that recording and go back. Okay. I had negative 8 and I subtracted 7. That means I have negative 15. Alright? Now, if that was difficult to do, you could also change it into being negative 8 plus the opposite of 7, or plus negative 7. And then we do it like we did the addition question. The signs are the same, so we add them up. 8 plus 7 is 15. Is it positive or negative? It's negative. So that was the rules for adding. If you switch the sign to addition, you have to also remember those rules for adding, which is why we did them first. Oh my goodness, negatives. This is one of those typical questions that you'll see on a test where it's like, why do you even do this to ourselves here? But with this type of question, every single time when I see that minus negative, I switch it to being a positive to try and make my life easier. Then I just go back to the rules of addition. If the signs are different, I find the difference. 11 minus 5 is 6. Is it going to be a positive 6 or a negative 6? Well, what do I have more of? I have 11 positives and I have 11 negatives and only 5 positives. There's more negatives, so my final answer will be negative 6. Oh my goodness, there's a lot of negatives. Alright, so let's review what happened. We did adding it.